To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all the G.C.E O-Level 2021 Paper 2. In the previous chapter, I discussed the first two questions of Part A. So, you all know Part A, there are 4 questions. All 4 questions are compulsory and you have to answer those questions in the space provided. And for each question, they give marks out of 15. So, the third question also is out of 15. Altogether, there are 4 questions, each one marked out of 15. So, in total, they are out of 60 marks. So, question number 3. In that Part A, and also I have told you all students in the introduction, this is a chemistry related question. Now, different questions 1, 2, 3 and 4, they are based on different lessons. So, the third question is based on chemistry units. So, here, question number 3A, how electrons exist in the energy levels belonging to atoms of elements L, M, Q and R are illustrated in the following diagram. So, the diagrams are given. L, M, Q and R are not the standard symbols of those elements. So, these are things that you need to consider. They are not standard symbols, not the standard symbols. Given on the right hand side is a periodic table indicating the places of the first 20 elements. So, here we have the elements L, M, Q, R and here we have the periodic table that indicates the first 20 elements. And in that also you can see they have marked the element L, that is this first element. So, now if we look at the elements, can you all identify them? Here you can see L has 2 energy levels. In the first one, it's 2 electrons. Then there are 4 electrons in the second energy level. So, that is how you can identify the element. So, here 2 and 4. Then atomic number is going to be 6. Then you all know it should be carbon because you are supposed to remember the first 20 elements, students. You arrange them in ascending order of atomic number 1 to 20. You should know their electronic configuration and each element. So, this has to be carbon that you can identify. Then if you take M, can you see? There are 2 electrons in the first energy level. Then 2, 4, 6, 7 electrons in the second energy level. What is that? Atomic number 9. If you can remember, it is fluorine. So, you can identify that also. No need to answer them using the real symbols or the standard symbols, but just for you all to get an idea. Then here you can see what is this element. 1, 2 in the first energy level, then 2, 4, 6, 8 in the second energy level, then there is 1 electron in the third energy level. So, 2, 8 plus 1, 11. Atomic number 11, you all know it is sodium. So, you can identify that as well. Then here, if you look at this, what is that? 2 electrons in the first one, 2, 4, 6, 8 in the second one. There is a third energy level, 2, 4, 6, 8 there. And there is 1 in the fourth energy level. So, that is 2 plus 8, 10, 10 plus 8, 18, 18 plus 1, 19 electrons. Atomic number 19. Because number of electrons equals number of protons in a neutral atom. Number of protons equals atomic number. So, this has to be potassium. You have identified all the elements also. Then, how can you relate them to the periodic table? That is based on their electronic configuration. You all know, students, the number of electrons in the valence shell corresponds to the group number. So, here this is 4 electrons. So, this has to be group 4. And the number of shells that contain electrons will be the period. So there are two energy levels or shells containing electrons. So that has to belong to period 2. So if you look at the position of L here, now this is L. There you can see group 4, group 4, group 4 you have to use Roman letters and period 2. So these are the information that you already know. If you are given the atoms like this with electrons filled in their energy levels, you can write the electronic configuration, you can get the atomic number, then you know the element as well. If you don't do that, even if you don't identify the atoms or the elements, still you can find the position by looking at the electronic configuration. I'm sure you all can remember that. Now with that, if we try to answer the questions, first one, using the given symbol. So here look at the question, using the given symbols, indicate the positions belonging to the elements M, Q and R in the periodic table as shown for element L. So element L we have found it's group 4 period 2. So here also I have already written the electronic configurations, but in the next slide I will fill up the periodic table. So already L has been filled up for you all. These are the same elements L, M, Q, R. It is given in color so that you can see it more clearly. I'm sure you will be able to fill them up here. So L has been already positioned. Now M, we already found that it is fluorine, but 2, 7. So 7 is the number of electrons. Here it is 2, 7. 7 is the number of electrons corresponding to the group number 7 and 2 shells, that means period 2. Then where does it go? It goes to this position. Group 7, period 2. Is that clear? Last energy level, the number of electrons is the group. The number of shells containing electrons is the period. Then, if you take Q, we identified is 281 as sodium. So, you know the position of sodium. But from this, if you are to identify, this is 1. So, it has to be group 1. And there are 3 energy levels containing electrons. So, it has to be period 3. Group 1, period 3 will be Q. Is that clear? Then, this last one R, we wrote the electronic configuration 2881. So, again, last shell has only 1 electron. So, group 1, but there are 4 shells containing electrons. So, period 4. Period 4 here and group 1. So, that is going to be R. Now, we have written the positions of the elements M, Q and R. L has already been shown, group 4, period 2. M, group 7, period 2. Q, group 1, period 3 and R, group 1, period 4. I'm sure you also can answer this correctly. With that, students, I'll move on to the next question. So, part 2 of the question. So, for you all to easily understand, I have already put the periodic table where we wrote the positions and the elements given to you all are given on top. Now, the second part, write the chemical formula of M existing in the gaseous state in the molecular form. So, you all know some of the elements, they exist as diatomic molecules. Now, molecule M, formula of M, we already found out that is in group 7, period 2, that is fluorine. So, you all know fluorine actually exists in the form of F2 molecules, F2 gas. That is what you need to write here. Write the chemical formula of M existing in the gaseous state in the molecular form. Here we have to write it as M2. The 2 has to be subscript because you all know that is the number of atoms in the molecule. So, we write it as M2. At the same time, since you have identified it as fluorine, you can also write it as F2 or you can write it as F2. Fluorine exists as F2 molecule, diatomic gas. So, both you get marks. Either you write it as M2 or you can write it as F2. Is that clear, students? So then, we'll move on to the next part. Third part, again here I have the periodic table with the position of the elements. Third one, what is the chemical formula of the compound formed by the combination of L and M? So to write the chemical formula, what do you need to know? You need to know the valency. Now you all can remember, students, valency in the periodic table. If you go across the periodic table from left to right, group number 1, 2, 3, 4, the valency equals the group number. But starting from 5, again the valency becomes 3, 2, 1, and here valency 0. Because they are noble gases, they do not form bonds. So the valency changes this way. 1, 2, 3, 4, 3, 2, 1. What is the reason? These elements form compounds in order to obtain the noble gas electronic configuration, which is the stable electronic configuration. To attain that, they need to have 8 electrons in their valence shell. So the first 4 elements, they have 1, 2, 3, 4 electrons in their valence shell. So if they use those for bonding, they attain that noble gas electronic configuration. But if you take group 5, there are 5 electrons. So if they share or obtain 3 electrons, they attain 8 electrons. So same goes for group 6. 6 has 6 electrons. So 2 electrons give them in total 8 electrons. Noble gas electronic configuration. Group 7, they have 7 electrons in the valence shell. They take up 1 electron. They attain the noble gas electronic configuration. Whereas group 8, the valency is 0. So this is valency. Now when you know the valency, it's easy to write the chemical formula. It is between L and M. How do you do that? L and M. L group 4, valency 4. M group 7, but valency 1. What do? You exchange the valencies. So this becomes L1M4. But you write it as LM4. When it is 1, you don't have to show that 1. So we write it as LM4. This is actually CF4 molecule, tetrafluorocarbon or tetrafluoromethane. So that is LM4. That is what you need to write here. What is the chemical formula of the compound formed by the combination of L and M? You don't have to show this working. You need to write the formula only. LM4. So with that, the fourth question, of L and M, which element is higher in electronegativity? What is electronegativity? When they form a bond. Now here they have formed a bond. Now in this bond, if you take the electrons, now L is going to be in the middle, M is going to be around it. But here you all know these are all covalent bonds. Now L gives an electron, M also gives an electron. But when you compare the abilities to draw the electron towards themselves, M has higher ability to draw the electron towards itself. Here, of course, the electrons will be more towards M. Why? M is more electronegative. If you have 2 elements, now here this is going to be carbon and fluorine. Out of that, fluorine will draw the electrons towards itself. That means fluorine is more electronegative. Whereas carbon compared to fluorine is less electronegative. So the ability to draw the electrons towards itself from a covalent bond in the bonded state is what we call as electronegativity. And in a periodic table, we all know, students, as we go across the period, what happens to the electronegativity? Electronegativity increases. Across the period from left to right, electronegativity increases. Electronegativity increases. And normally group 7, that is group 7 of the period, has the highest electronegativity. Why? Group 8 does not form bonds. So we don't have group 8 in the electronegativity scale. You can remember the Pauling's scale. In that, group 8 is not assigned a value for electronegativity. So across the period, electronegativity increases. Down the group, it decreases. Down the group, it decreases. So here, if you compare L and M across the period, M will have the highest electronegativity. Is that clear, students? So here, if we write the answer, of L and M, which element is higher in electronegativity? It is M. Here also we write it as M. Is that clear? So with that, I'll move on to the next question. Then the fifth one. Same periodic table is given with the elements in their position. Of Q and R, which element is lower in first ionization energy? What is the first ionization energy? You all can remember, students. So if you have an element, let's say A, if A becomes A positive, losing an electron, in the gaseous state. These have to be in the gaseous state. When you have 1 mole of a particular element in the gaseous state, when they lose an electron from each atom, forming a unipositive ion in the gaseous state. The energy that needs to be supplied is what we call as first ionization energy. So all the elements have a first ionization energy value. You can remember how it changes. Across the period, from left to right, they increase in a certain manner. Whereas down the group, they decrease. Because the size of atoms down the group from top to bottom increases. Because of that, the first ionization energy decreases, but across the period, it increases. So out of Q and R, which element is lower in first ionization energy? So like I told you all, down the group. Now here, down the group and across the period, first ionization energy here of course increases in a pattern. Here of course it decreases. Here it decreases because the size increases. But this way you all can remember there is a zigzag pattern. Group 1, then group 2 increases, group 3 is slightly less, group 4, group 5 high, then group 6 is slightly lesser than group 5, then group 7, group 8. And in a period, group 8 has the highest first ionization energy, group 1 has the lowest first ionization energy. But here, they want you to compare Q and R. Both belong to group 1. Down the group, the first ionization energy decreases. So here, the lowest first ionization energy is going to be R. Lowest first ionization energy is R. Is that clear? Then the fourth one. State the acidic basic nature of the following oxides formed by L and Q. Now L is group 4. We have already identified it as carbon. So that is carbon dioxide. So you all know, students, carbon dioxide. And Q, we know it is sodium. So sodium Na2O. And you all know, across the period, again from left to right, the metals form basic oxide. So metals, basic oxide. Normally metals, basic oxide, and non-metals, acidic oxide. This is something you know. So, you all know, students, as you go from left to right, the basic nature decreases, acidic nature increases. For oxides, here we can say this way, basic nature decreases, acidic nature increases. That also you all know. So, these are usually metallic elements. They form acidic oxide. This side, it is the metals that form the basic oxide, whereas on this side, usually it is the acidic oxide. So, if you compare CO2 and Na2O, that is Q, that is a basic oxide. Whereas carbon dioxide, that is the oxide of L, is going to be an acidic oxide. So, that is what we need to write here. Here this should be metals, basic oxide. So, then if we write the answer, LO2, that is group 4 carbon dioxide, is acidic. Here they have us state the acidic basic nature, and Q2O basic. So, in this, students, I am giving you all the additional and required information related to these questions. Directly you can answer them, but this is like a revision where I am giving you all the required information. I am sure you can understand that. With that, I'll move on to the next one. So, here, the 7th part of the question. The diagram illustrates how Q exists in the ionic compound formed by the combination of Q and M. Draw how M exists in that compound. So, they have given you Q here. Now, Q you all know is sodium. So, normally sodium forms sodium ions because they have said ionic compound by losing an electron. Whereas you need to find the ion of M. M is group 7, that is fluorine. So, M you all know is fluorine, takes up an electron and becomes F minus. The electrostatic interaction between Na plus and F minus forms the ionic bond. Now, here they have shown the Lewis diagram. So, there you can see they have shown Q here. The nucleus, 2 electrons in the first shell. Now, this is sodium after losing 1 electron, Na plus. Here you can see positive charge. So, the third shell which had the 1 electron, that electron had been lost. So, there are only 2 energy levels containing electrons. So, 2 in the first shell, 8 in the second shell. You have to draw them within square brackets. You have to put the charge at the right hand top corner. So, the positive ion is shown here. Now, you have to show the negative ion. Now, negative ion, you all know, students, fluorine 2, 7. But when it takes up an electron, it becomes 2, 8. But out of those 8 electrons, 1 is from sodium. The electron lost by sodium is taken up by fluorine. So, you need to indicate that as well. So, here you need to show the nucleus, then the first energy level, second energy level. So, in this, I'll use a different color to denote the electrons. Now, we will use crosses for fluorine. So, 2 electrons, then there are already 7 electrons in fluorine. In addition to that, there will be 1 electron from sodium. So, we use different symbol, dot and cross. Since the dot is used for Q, I use cross for this one, that is M. So, M, there are 7 electrons in the valence shell, but the 8th one is from sodium. So, you show it with a different symbol. So, this is dot, this is cross. And what else do you need to put? You have to show the negative sign there. Is that clear? You have to show the negative sign here. So all these are important. You need to draw the exact number of energy levels. So there are 2 energy levels. In the first energy level, 2 electrons. Second energy level, there were 7 electrons. But after taking up an 8 additional electron, it becomes 8 in total. And in that also, the previously existing electrons are shown by one symbol cross. The new electron that was gained from Q is shown by a dot. So this is the complete diagram. Draw how M exists in that compound. So this is how M exists. Is that clear, student? So you can show it as M or you can even show it as fluorine. So this you can even show it as fluorine F, because we already know Q is sodium and M is fluorine. Is that clear? So if you draw all these and show the negative charge, then you will get full marks. Now here you are going to answer on the paper, so you just need to fill it, draw the iron within these square brackets and put the negative charge. In case if they haven't given the square brackets also, still you have to draw the iron, put the brackets, square brackets and then show the negative charge. Is that clear, student? So this is how we represent an ionic bond. So with that, I'll move on to the next part. So this is part B of the question. Up to now, we answered questions related to part A. Those were also from a chemistry lesson. Now here also, this is related to chemistry again, bonding. Now B part, chemical bonds within the water molecules and among the water molecules are indicated in the diagram by the arrows 1 and 2 respectively. Using it, fill in the blanks in the following sentences. So if you look at the molecule, you all can see the water molecule. You are familiar with these, students. Now water, oxygen, forms 2 covalent bonds with hydrogen. At the same time, there are 2 lone pairs on oxygen. And oxygen has a delta negative charge and hydrogens have delta positive charge. Why is that? Because the OH bond, because of the electronegativity of oxygen, we discussed that previously, it draws the electrons towards itself from the bond. Because of that, it gets a partial negative charge. Hydrogen has a partial positive charge. This is more electronegative, this is less electronegative. So because of that, this is a polar covalent bond. A polar covalent bond, you all know that. Polar covalent bond. And this polar covalent bond, the molecule is also polar molecule. When it is a polar molecule, anyway there is an intermolecular interaction between the hydrogen of this molecule and the oxygen of another molecule. So that is what is shown there. That is the intermolecular bond or the hydrogen bond. So this is the intermolecular bond. Molecular bond or the hydrogen bond. Hydrogen bond. Now, intramolecular means within the molecule. Intermolecular, between 2 molecules. Now, this is a highly electronegative element that is bonded to a hydrogen. Between that hydrogen and another highly electronegative atom, the intermolecular bond is a hydrogen bond. Because of this hydrogen bond, these water molecules or water compound has special properties. It has high boiling point, it exists as a liquid at room temperature, and also the differential expansion in freezing, all that is related to this particular intermolecular bond. And high specific heat capacity, all that related to this. You can remember that. So now if we answer the questions. Here you can see the same diagram. You can see hydrogen, hydrogen 2 bonds, oxygen with the lone pairs. Then here another molecule of water. Again you can see the lone pair and the OH bonds. Between oxygen of one molecule and hydrogen of the second molecule, they have shown the second bond. That is actually the intermolecular interaction or the hydrogen bond. So the first one. The bond type indicated by the arrow 1 is known as, so arrow 1 is covalent bond. So here covalent bond. Covalent bond. And the bond type indicated by the arrow 2 is known as, here you can see intermolecular bond. Intermolecular bond. Or you can say hydrogen bond. Normally in covalent compounds between the molecules there is intermolecular bond, but in this case that is hydrogen bond. So you can give either of the answer. Is that clear? Then second one, the type of bonds indicated by the arrow blank is responsible for the existence of relatively higher boiling point of water. So I mentioned that it is bond 2. So there you have to write the letter number 2. The type of bonds indicated by the arrow 2. 2 corresponds to hydrogen bond or intermolecular bond. Then the third one. A very small blank charge lies on the hydrogen atoms in the water molecules. I showed you all there is a positive charge. So here we can write it as delta positive, or you can write it as positive, or just you can write it as positive, because here they have said a very small positive charge lies on the hydrogen atoms in the water molecules. That is correct. Or else to show it is a partial positive charge, you can use it as delta positive. Is that clear? Either way you get the marks. So for this one and this one you get the full mark. You can either write intermolecular bond or hydrogen bond there. Here delta positive or just positive charge here. Is that clear? So with that students, we have completed the third question of part A. Now I am going to move on to the fourth question. So as you all know, this whole full question is out of 15 marks. With that, I'll move on to the next question. So question number 4. This you all know, normally it is a physics related question. So if you look at part A, ABCD is a horizontal path. So here they have shown the horizontal path ABCD. I'll read the question first. You can see ABCD. The distances between the points AB, BC and CD are equal. So from AB, BC and CD, the distances are equal. The parts of the path AB and CD offer friction. So this part and this part offer friction. There is friction. A trolley of mass 4 kg was placed at A and a horizontal force of 12 Newton was applied as shown in figure. So here a 4 kg mass trolley, a force of 12 Newton was applied, and then you can see when the trolley reached B, the 12 Newton force was removed. So as it reached B, the 12 Newton force was removed. But here you can see they have shown a force of 4 Newton. So you all know at this point where the wheel is in contact with the horizontal surface, if they show a force in the opposite direction, you all know it is the frictional force. Frictional force exists in 3 stages. The static friction, limiting friction and the dynamic friction. Now here when there is a force applied, if the trolley is moving, that means this has to be the dynamic frictional force. So you all know. And the resultant or the unbalanced force will be the difference between the applied force 12 Newton and the frictional force 4 Newton. because they are acting in opposite direction. So here you can see this is 12 Newton, the higher force. So the trolley will move in this direction. So it moves from A to B. Then once it comes to B, the force is removed. Then you can see the trolley that entered part CD came to rest at D. So initially they applied the force. It went from A to B. At B, the force was removed, but still the trolley moved up to C, and finally it came to rest at point D. And here there is no friction. At this point, no friction. Because they said no. A to B and C to D, there is friction. B to C, there is no friction. So only the velocity of the trolley. The frictional force acting on the trolley when moving in the parts offering friction was 4 Newton. So that is also given. I mentioned to you all since it is shown this way. So here this way 4 Newton force. Now at this point B to C, now if we just summarize that, you all can understand students, A to B, there is a force of 12 Newton acting this way and a force of 4 Newton acting this way. So the resultant you all know is going to be the difference. It's going to be 8 Newton. If there is an unbalanced force, obviously there should be acceleration. That you can understand. But when it reaches the point B, between B to C, there is no friction and no force applied. Force applied. Why? They stop applying the force of 12 Newton at point B. So will there be an unbalanced force? No. There is no unbalanced force. Then what will happen? Now there is a velocity for that trolley due to this 8 Newton force when it reaches point B. But after that there is no forces acting on it. Then according to Newton's first law, when there is no unbalanced force applied, an object at motion will move with constant velocity or uniform velocity. So here this is going to be constant velocity. Is that clear, students? After that, what happens? When it reaches point C, C to D, so when it comes to C to D, there is no applied force, but there is a frictional force of 4 Newton. Because they have said no. From C to D also there is a frictional force of 4 Newton. Now the trolley is moving this way, movement, and the friction is in the opposite direction. Then what will happen? There is an unbalanced force acting opposite to the movement of the trolley. So then it will decelerate. It will decelerate. So here it's going to be deceleration. Is that clear, student? So from the given information, these are all what we can understand. So here, according to the given data, from A to B, there is a 12 Newton force in this direction, frictional force 4 Newton. There is an unbalanced force. Because of that, there is acceleration or uniform acceleration. But at B, they stop the 12 Newton force and there is no friction. So, no unbalanced forces. The trolley will move with uniform or constant velocity up to point C. But at point C, from point C to D, there is friction. So, then there is a force acting against the motion of the trolley. So, because of that, it will start decelerating. So, there will be deceleration there. Is that clear? So, with that, we'll answer the questions. First one, indicating the nature of the motion of the trolley from A to D, complete the following table. So, here nature of motion of the trolley. In this, we have the positions from A to B, from B to C, and from C to D. Already from A to B is filled up for us. It is acceleration. We understood that. Then B to C, it should be uniform velocity. So here you can see uniform, or you can write constant velocity. Uniform or constant velocity. Now again students, normally you need to write only one answer. So this box would be more than enough for y'all, but here I am writing the possible terms. So uniform velocity or constant velocity. Then from C to D, we said it's going to be deceleration. So here also the term uniform is not necessary. Here they have given acceleration. So the same way here we can write deceleration. You don't have to say uniform deceleration, but here the term uniform is important. Why? There is no unbalanced force. So according to Newton's first law, it has to be or it should be uniform velocity. So you have to say that. Then here this is deceleration. Deceleration. Is that clear, student? Deceleration. So A to B acceleration, B to C uniform or constant velocity, C to D deceleration. With that, I'll move on to the next part. Part 2. On the following system of axes, draw the approximate velocity time graph for the motion of the trolley from A to D. So you need to show the motion of the trolley. The axes are marked for us. You can see y-axis velocity, x-axis time. So you need to draw the velocity time. So initially it is going to be acceleration. Acceleration starting from the point of origin, then uniform velocity, and then deceleration. So you can also mark the points A to B, B to C, C to D. So A to B is that one, B to C, C to D. Acceleration, uniform velocity, and deceleration. Is that clear, students? For each region, you will get 1 mark. So graph like this, if the axis is not labeled, you have to label the axis. For that also you will get a point. But here of course the axes have been already labeled to you. So then you don't have to do that, but you have to draw the shape. For each region, they will give you marks separately. So 1 mark, 1 mark, 1 mark, it will be out of 3 marks. Is that clear? So with that, I'll move on to the next part. This is part 3. What is the unbalanced force acting on the trolley in its motion from A to B? So already I calculated the value, but just for you all to remember, the force or resultant force, you can remember 12 Newton in this direction. So minus 4 Newton in the opposite direction. So it is going to be 8 Newton towards this direction. Here of course I have just shown it for you all to understand that it is in opposite direction. That is why we take the difference. So 8 Newton. Here you need to write the value 8 Newton. Unbalanced force. What is the unbalanced force acting on the trolley in its motion from A to B? So you need to write the final answer there. Is that clear? So with that, the next question or next part. Part 4. Calculate the acceleration of the trolley during its motion from A to B. Now earlier they asked what is the unbalanced force. Here calculate the acceleration. So to calculate the acceleration, what do you need to use? You need to use the equation for Newton's second law. F equals ma. Force is equal to mass into acceleration. So if we use that, F equals ma, and if you rearrange, A is equal to F over m. So F we have calculated as 8 Newton divided by 4 kilogram of trolley. So you will get the answer as 2, 8 divided by 4, 2, and acceleration meters per second square. Now here students, you have to remember, you have to write the equation. This and this you can write, or else you can at least write this equation. You have to substitute. But they are writing the units here during the substitution is not compulsory. But the final answer should have the unit. Here the units are important. Units is important. Without the units, you won't get the full marks, or sometimes you don't get the marks at all. So always for a calculation, if the quantity has a unit, you have to write the unit. So answer is 2 meters per second square. If you do all these, you will get the full marks. Now sometimes in these type of questions, they give 1 mark for the equation, 1 mark for substitution and 1 mark for the answer. Then it will be 3 marks. Otherwise, 1 mark for half. So 1 mark to write the equation and substitute, and 1 mark for the final answer. Then it will be 2 marks. Is that clear? So remember, in a calculation, the final answer should have the unit. If there is a unit. If there's no unit, then no problem. Otherwise, you have to write the unit. Write the equation, substitute and calculate. Give the final answer with the correct unit. If you need to do a unit conversion, you have to do that as well. Is that clear? So with that, I'll move on to the next part. So here we have part B. The previous one was part A. Again, physics related question. This is also a physics related question. So the fourth question of part A of paper 2 is a physics related question. Part B. The diagram shows a pan balance used in a retail shop. So if you look at the diagram, students, you can see this is a pan balance. The two pans, the weight is put here, and this side sugar. Here you can see it is suspended from a string. So this actually gives rise to equilibrium of moment of forces. So this side there is the clockwise moment of force. This side there is the anti-clockwise moment of force. Why? There is the distance and the weight is the force. So moment of force. This side also there is the weight, that is the force, and this is the distance, and that is the point of rotation. So you all are familiar with this particular setup, a pan balance. The first question of us part, when 1 kilogram of sugar is placed on one pan of the balance, what is the mass of the weight that should be placed on the other pan to counterpoise the balance? So mass of the weight, you have to look at it carefully. Just because you read the word weight, don't write it as weight, because mass comes in kilograms, weight Newton. Weight is a force, so you all know that. But here they have given the value 1 kilogram. So you know, if this is 1 kilogram, obviously you need to have 1 kilogram here, so that counterpoise means it would be balance, counterbalance. This side, the counterclockwise moment will be balanced by the clockwise moment. So for that, if there is 1 kilogram sugar here, there should be 1 kilogram weight there. So that is what you need to write here, 1 kilogram. Is that clear? So here also you have to write the unit. Is that okay? So with that, I'll move on to the next question. So the same B part, the diagram is given to you. Second part of the question. What is the force acting on the string by which the balance is suspended when it is counterpoised as mentioned in part 1 above? The mass of the balance only is 3 kilogram. So the mass of the balance is 3 kilogram. So if you just note it down here, this balance is 3 kg. Now here there is 1 kilogram, and here also there is 1 kilogram when it is counterpoised. So altogether there is 1 kilogram, 3 kilogram, 1 kilogram, all of them acting downwards. So all these forces have to be balanced by the string. So you need to find the force acting on the string. So for that, if we just to show you all the diagram, if I draw it, now here we have all three like that. So you know this is 1 kilogram, this is 3 kilogram. I am marking the balance only, then 1 kilogram of weight. Sugar, the balance, then the weight. So here it is the tension. So this tension should be equal to all these forces. So how do you calculate that? You calculate the total mass. Mass 1 plus 3 plus 1. So that is 5 kilogram. But to find the force is equal to what? Equals m into g. So mass is 5. Gravitational acceleration is given to you as 10 meters per second square. So that is 10. That will be equal to 50 Newton. So the force acting on the string will be 50 Newton. Now, in your question paper, students, you don't have to draw this and all that. You need to only find the force. So if you write it as force F equals mg and 5 into 10, here itself you can show the addition also. 1 plus 3 plus 1, and then if you multiply by gravitational acceleration and find the value 50 Newton, that is correct. Is that clear? So here also final answer should have the unit 50 Newton. With that, I'll move on to the next part. So this is another diagram given to you all. If we read the question first, you can see the figure shows a flow balance. Now this is a different type of balance, a flow balance used in a wholesale store to weigh a large mass. Now the previous balance, the pan balance for small masses. This is for a large mass. A mass of 50 kilogram is placed on one side of the balance and a weight of mass m is suspended on the other side so that the balance is counterpoise. So here you can see the term counterpoise. So earlier also you came across that term. Counterpoise is it's balanced. So when we say counterpoise, there is the moment of force. This side is anti-clockwise, that is balanced by the clockwise moment of force. If you look at the diagram, here you can see point O. From there to this side they have marked 5 centimeters, and here you can see weight as mentioned there 50 kilogram. That is the weight of the object what is going to be measured or weighed. And on this side you can see 100 centimeters. This arm is longer. So here you have a weight m. Mass is m, the weight is shown. Here you can see the scale is shown to you. So here also the moment of forces are balanced. Using that you measure the weight of the object. So then if you look at the question A, find the moment created around point O by the mass of 50 kilogram. Moment is this side. So you all know the equation for moment, students. It is moment F into D. Moment equals F into D. Force into distance from point O. So here the force mass is given 50 kilogram, but you all know force mass into gravitational acceleration. So 50 into 10, that is going to be the force in newtons, into, you need the distance. Normally we use the standard unit, so that is in meters. So we divide 5 by 100 in order to get the distance in meters. So if you calculate it there, 500 Newton into 5 over 100 meters. So when you simplify, these gets cancelled off. So 25 Newton meters. This is in standard units. We have calculated in standard units the moment of force in Newton meters. At the same time, you can also calculate it as moment F into D. Here you need to find the force 50 into 10 newtons, but you can give the distance in centimeters. That is also accepted. So 5 centimeters. So that is going to be 500 Newton into 5 centimeters. That is 2500 Newton centimeters. Like that also you can keep. Normally you are used to this method because we use the standard units force Newton and distance meters. But you can give the answer this way as well. Is that clear, student? So with that, I'll move on to the next. Here the same part 3, in that the B part of the question. Write an expression in terms of m for the moment created around point O by the weight. So moment created around m. Here you can see it is the mass m, not weight. So here also you need to convert it to weight. So moment equals F into D. So what is F? Mass m into gravitational acceleration 10. We already wrote the equation, so you can directly multiply it, mass into gravitational acceleration into distance what? 100 centimeters. So there again we can divide that by 100, so you will get the answer in meters. So this is going to be in newtons. So 10 m, here 100 and 100 gets cancelled off into 1 meter. So that is 10 m Newton meter. Is that clear? So this 10 m is the value. 10 m is the value, not a unit. 10 m Newton meter. They have asked you to write an expression in terms of m for the moment created around point O. So there, the answer you can write moment equals 10 m. You don't have to show the unit. It's only the expression they need. So 10 into m. You can write it as 10 m or 10 into m. Or you can even write it as 10 into m. That is also fine. Is that clear, student? So that is how you can calculate the moment exerted by the mass m. Is it clear? So with that, I'll move on to the next one. Now here in the same third part, we have the C part of the question. When the balance is counterpoised around point O, that is when the balance is balanced, it's at equilibrium. The anti-clockwise moment created by the 50 kilogram mass and the clockwise moment created by the weight are equal. Find the value of m. So this is the anti-clockwise moment, this is the clockwise moment. They are equal, so you are supposed to find the mass m. So we found the moment for this one, 10 m, that is equal to, this is 10 into m, and this side we found it as 25 Newton meter. You can remember that. If I go back just to show you all, here we found it as 25 Newton meter. So I will write it as standard units. It's easier for us to calculate. So 10 m is equal to 25 Newton meter. So therefore you can find m as equal to 25 over 10. That is going to be equal to 2.5 kilogram. Because m is the mass. You have to remember that, students. Here it is the mass m. So therefore you will get the answer in kilograms. 2.5 kilograms. Is that okay? So here also you need to balance it. Clockwise moment, anti-clockwise moment or counterclockwise moment, they are equal. So 10 m is equal to 25 Newton meters. When you calculate, you get the answer in 2.5 kilograms because it is the mass. Is that clear? So then, D part of the same question, here you can see state 2 advantages of using a flow balance instead of a pan balance for measuring a large mass. So in the first part of the question, you saw it is the pan balance. There, the balance has to be suspended from a surface. But here, this is a flow balance. So what do you think is the advantage? Now, with a flow balance, the weight is 50 kilogram that is being measured. So, a large weight can be measured and it is easy to handle because it is a flow balance. So, that is one answer. It is easy to handle. Or you can say easy to measure a large mass. Easy to measure a large mass. That is one advantage you can write. Then what do you see here? This arm, the distance is 5 centimeter. This arm, the distance is 100 centimeter. And in the previous one, we calculated the value for M, 2.5 kilogram. To measure a weight of 50 kilogram, you only need 2.5 kilogram weight. So that means to measure a heavy mass, you only need small weights. So that is also an advantage because of this setup. Because this arm is longer, this arm is shorter. The distances, they are related to moment. So because of that, we can use small mass as the weight. So that is another advantage. Small weights can be used. So that is also an advantage. So it's easy to handle because it's on the floor, easy to carry and lift the heavy object and place it on the balance like this. At the same time, we use small weights. So both of those are the advantages of using this particular balance. So with that, students, I have completed the fourth question as well. Now this fourth question, A part, B part, all the parts in that together is out of 15 marks. So here, since it's a physics question, there were many calculations. All the calculations, you have to write the equation wherever necessary and you have to have the units if the final answer has a unit. Without the unit, you might not get the full mark or you might not get the marks at all. So you have to show the working and the final unit. Is that clear, student? And so far, from the 4 questions, you all can see these are very short answers. Now, apart from just a sentence like this, most of the answers were very short because we write the answer in the space provided. So you don't go to write very long answers. Stick to the short answers. So with that, I have completed part A of paper 2 of G.C.E. O-Level 2021 paper. With that, I am going to end this chapter and in the next chapter, I will discuss the questions in part B with you all.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.